We'll start the session. Hello, everyone. My name is Akshay, and today I'll be the presenter for the session on Scapy. So, before we go into the details, a bit about me. I'm a senior technical leader in the Bangalore Security TAC team. I have been with Cisco for close to 12 years now. I have worked on a lot of Cisco security products, which include Cisco's ASAs, next-gen firewalls, Cisco ICE, Cisco's multi-cloud defense solutions, Cisco VPN solutions. So throughout my career, I have seen a lot of problems coming in from customers, a lot of cases coming in from customers. And one of the common requirements which working with customers, which I have seen, is the ability for the customers to recreate the problems in their environment. In a lot of cases, we cannot get logs because the problems might be intermittent. They cannot share the logs with us because of whatever XYZ reasons, right? So in those cases, we generally tend to recreate those problems in our lab. And that is where I identified and that Scapy is a very useful tool. So in this 30-minute session, we'll go deep. We'll do a bit of deep dive into Scapy, what Scapy is, what are its capabilities. We'll look into how to install Scapy, how to perform some of the packet crafting stuff on Scapy, how to do a packet sniffing using Scapy, and how to replay the packets. Any of you here worked on using Scapy? Okay, we have. Anyone else? Okay. So it's an introductory level session, so you don't have to worry about anything. You will definitely learn something out of this session. So what is Scapy? Scapy is a very powerful tool. It can craft packet from scratch. When I say craft packets from scratch, that means that you can configure each and every field of a packet. You can create a packet, you can use any layer 7 protocol, any layer 4 protocol, you can create everything, and you can send that packet back onto the network. And not only that, you can have an existing packet and you can modify each and every field of that packet. And that, again, you can send it back into the network. So it is very useful for protocol analysis as well. If someone is learning about networking, it gives you a very good insight into the different layers of the protocol, different fields which are there within each protocol. So if you're learning about it, then also it is a very good tool for expanding your expertise into network protocols. So one of the things is that why to use Scapy, right? I'll give you an example, right? In all of your organizations, you might have seen some fire drills that happen. They prepare you for an incident which might never happen, and we wish that never happens. But the protocols have to be in place, the processes have to be in place so that if in case a situation arises, everyone is prepared. Similarly, in any organization, we need to have cyber drills because you need to be sure that if you have a server, that server is resilient to the attacks or not, right? You should not know it when the attack already has happened, but you should be able to test all those things beforehand. So Scapy is one tool that without the need of a very sophisticated testing environment, without the need of a very sophisticated tool to generate attacks, you can quickly create something over here and you can just run it over the network. The installation of Scapy is very simple. It can be done using two ways. The first one is you can install it using a Python. We call it a pip install method, wherein you can create a Python virtual environment that is optional. And then you can just do pip install Scapy. That's it. And you are ready to go ahead and use Scapy. The other option is you can directly clone the Scapy repository and you can just run you can go into that folder and do run Scapy. The advantage with Scapy is that you don't need to know a lot of Python, right? And we as network engineers, we are okay with Python, but we are good with networking. So it is an advantage for us that you can still utilize Scapy with all the capabilities with not a very expert level Python knowledge. So once this is installed, I'll do a lot of demos in order to show how to craft a packet, how to send the packet. But please be careful that whenever you are doing it, make sure you test it beforehand before doing it in a production network, because your firewalls may detect that as an attack, and it might impact some of the servers as well. So you have to be a bit careful in terms of when you are doing it, how you are doing it, and how you want to do it, right? So let's see it in action. I hope the font is visible at the back. Okay, great. So I've already installed Scapy because I didn't want it to waste any time installing it. So it is already installed. I'll just go to, okay. So Scapy provides you an interactive CLI, which we call as the REPL CLI. So through this, you can run any Scapy commands here. Either you can run it from here. Scapy is also available as a Python package. So you can import that into your uh, program as well, into your code as well, using the import method. Now, what are the different options that we have here on Scapy, right? The first command that we'll see is the ls command. So I have added all these commands at the end of the slide in the backup slide. So later on, you can download the slides as well. So don't worry about the commands. So ls command, what it does is it gives you all the different protocols which are supported by Scapy. Let's say you want to look for what are the different fields in a TCP, right? If you just do ls of TCP, it will give you all the options, all the header fields which are available within TCP. What you see on this side are all the default options, what it will have when the packet is created. And you have the ability to modify each of these fields. You can put anything in this field as you want, provided within it is within the protocol limits, right? Like if it's a 32-bit field, you can put it only 32 bits in that. Similarly, if I want to look something for IP header, I can just do ls of IP and it will show me the details about all the fields. The other command which is there, which is very useful, is lsc. The first command was ls, the second command is lsc. What it basically does is it gives me the information of all the options which are supported within Scapy. So with Scapy, these are all the different options which these will be required in order to send the packet, in order to sniff the packet, in order to flood the packet over the network. If you want to look at the individual command details, like how you can configure and do other stuff. So let's say if I do help of send, it will give me all the options, how you can utilize this command in order to send the traffic. Now let's go directly into the packet crafting part. Let's say you have to create a packet, right? So a packet is more like a cake, right? A layered cake, wherein the bottom layer you can consider it as Ethernet. On top you have an IP layer, then you have a TCP or a UDP or whatever layer 4 you want to have, and then you have a layer 7, right? Now let's say I want to create a packet. The first thing which I need is an Ethernet layer. So let's say if I do A equals to ether, that's it. I have an Ethernet layer ready. If I want to see all the options, what are there in the Ethernet layer, I'll just do a.show. So I've stored the value of ether in a variable, and I'll just do a show for that. And it will give me what are the different fields with which it has created the packet. Now, all these fields you can modify. So if I want to modify, so over here, if you see, the first thing is destination. Destination is the destination MAC address. If I just do and I put in the MAC address, now it will create a packet with dead as the destination MAC address, right? If I do a.show now, you will see a packet with a destination MAC of dead. Now, what if I want to create an IP header? It is equally simple. I'll just do B equals to IP. Now, if I look into the details of the packet, it will show me that, okay, it has created an IP header with an IPv4 with an initial header length of 0 because we don't have anything. Source destination IP, it is loopback address because I haven't provided any address so far. Now, if I provide a destination address also, now it has automatically populated the source address as well. This source address is the NIC interface address of this particular virtual machine where I'm running this, right? So it automatically identifies that what is the default configuration and it puts that entry into the source information. And the same thing is whatever destination I have provided, it will provide that information into the destination address field. Now I can modify source address also. I can spoof the source address and put in any IP address there and it will still send the packet out. Now let's say I want to, just for testing, I'll just create an ICMP header also. Okay, so now I have created three packets, three fields. One is the Ethernet layer, the other layer is the IP layer, the third layer is the ICMP layer. Now, how do I create a packet out of it? That is where we call it as the stacking option. So what you can do is that you can create a variable which can just do ABC, A/B/C. So what it will do is that it will stack the Ethernet layer on top of an IP layer on top of Ethernet layer and the ICMP layer on top of the IP layer. And now you have the packet, which if I will see, I can see all the options which are there. Now I need to send this packet over the network, right? Now I have an Ethernet layer, I have an IP layer, I have an ICMP layer. I want to send it. What option should I use? That is where we have send P. What send P does is that send P we use when we have an Ethernet layer also within the packet. So if you have already an Ethernet layer which you have crafted, then you should use send P as an option. And when you use send P, it will utilize that layer 2 information in order to send that packet over the network. And that's it. It has sent the packet over the network. So whichever device it is, it should receive the packet provided the MAC address is correct. The destination MAC is correct. Now, what if I don't want to populate the MAC address at all? Means I just want the IP header and the ICMP header because I don't want to take the pain of identifying what is the MAC address of all the devices. So what I can do, I can create a new packet now with just IP header and ICMP layer. So if I see this packet now, it will have an IP header and it will have an ICMP header. Now the good thing with Scapy is that Scapy there is a full stack which is built within Scapy itself. It doesn't uses the systems protocol stack. That means that if I have to send it, what it will do is that it will send out an ARP request first. It will learn that ARP response and create the Ethernet layer on its own. For that, we will have to use just send option. Now the send option, what it will do, it will create the layer 2 header on its own and utilize whatever the layer 3 and whatever the layer 4 information which we have specified, and it will send the packet over to the network. Now, with send option, we have just sent the packet. We haven't captured the reply back. What if I want to capture the reply back as well? For that, we have another option which is called as SR. So now, instead of with SR option, what I will do is I will send the packet and I will capture the response back as well, so that I can look into that response and maybe modify it and then send it back, or receive that packet and then modify it. So let's say if you have to create a TCP 3-way handshake, then you send the SYN packet, then I need to capture the SYN ACK packet in order to create the ACK packet back. So that is where you have to, in some cases, you might need to capture the packet back as well, just to see what response is coming. So what I have done is I have used the SR option, sent the packet out. Now I'm capturing the response back. The response is basically two-tupled response, wherein I have the results in the sense that whichever packet I sent, how many were responded back. The other one is the unanswered one. Like if I sent something and I didn't receive any response back, those packets will come in the unanswered one. Now, if I do res of 0 dot summary, now what it will do is it will give me a summary of all the packets, all the requests and the responses that were received. So if you see here, this was the request that was sent, and then this is the reply that was received back. So this way you can capture, you can send the packet, you can capture the response back as well. Now, let's say if I want to, I've sent out an ICMP packet. What if I want to send out a UDP packet? So very quickly, I can go ahead and create a DNS request, right? With this DNS request, what I have done is that this is exactly same IP header. Then on top of that, I have stacked a UDP header with a destination port of 53. And on top of that, I have stacked a DNS layer as well. Now, how will you know that what all options to put in this space, right? You can either Google it out, or the other option is I can create a new packet with DNS, a default packet with all the default options. Now, what this will show me, all the options which I can use, which I can modify. And then you can use these fields in order to populate all the headers within your packet itself. So what I did here is I use that information in order to create a DNS query with a query name of cisco.com and a query type of A. That means I'm expecting an IPv4 response back. Now, if I do the response, I should be able to see the IPv4 response, which is coming, IPv4 reply packet I captured, and I should be able to see the IPv4 response packet. Now, what if I want to make it a quad A query? I can immediately do it by changing the query type. And just by making change in one simple parameter, I can now get the IPv6 address as well for cisco.com, right? So with very small changes, very minimal effort, you can make a lot of changes within the packet, and you can validate how the response is coming back. You might have seen, or you might have experienced in your network as well, a TCP flood attack, right? What is a TCP flood attack? It is basically you send a lot of packet to a server. You send a SYN packet to a server. The server responds with a SYN ACK, but you never respond back with an ACK, right? So that in a way is you are exhausting the connection table of the server, or it can exhaust the connection table of maybe a firewall in between. But how do you know whether your servers are resilient to those type of attacks, or whether your firewall is protecting you against those attacks or not? If you have an intrusion prevention device, then whether it is tripping those signatures which are relevant to flooding, is it doing that or not? So how do we ensure? How can we quickly test that using this? So to identify how to test it, what I can do is I can quickly create one packet. So rather than creating each individual layer separately, I can add it over here as well. Okay, so I have added a destination IP address. I have added a destination port, and I have added a SYN flag. So now what it will do, if I do send this, it will send one packet out to that server with just the SYN packet. Now, if I have to send this in a loop, I can quickly create a range, and I can just do send of this packet. And now what it will do, it will send it 10 times. If I do it 1,000, it will send it 1,000 times. If I do it million, it will do it a million times. So that way you can very quickly identify whether your server, whether your IPS is tripping those signatures or not when this traffic is going, or whether your server is resilient to those attacks or not. Any one of you heard about the Christmas attack? Right. So Christmas attack is, again, since Christmas is just 1 month away, right? So let's just quickly see what's a Christmas attack. So in Christmas attack, what happens is we send certain TCP flags and then send out the packet out. So flags which are not expected to be enabled together, just like an urgent bit, push bit and a fin bit together. When you have urgent bit, push bit, and a urgent bit, push bit, and a fin bit set together, what happens is that many times servers are not able to identify what they have to do with the packet, and they end up consuming a lot more CPU while processing the packet. Now, the reason why it is known as a Christmas attack is because if you see, it's these zeros and ones kind of look like it's lighting up a Christmas tree. So that's how the name came up. Now, if you have to generate this type of a packet, how will you do that? It's again very simple, very straightforward. If I have to create a TCP header with, let's say, I'm putting a destination port of 80 and a flags of urgent push fin. That's it. So now I have a TCP layer which has these flags enabled. And now if I have to send it out, I can instantly do a send of IP destination address 10.0.0.12. And then I can put in and then I can attach that, stack up that TCP layer on top of it, and I can just send it out. So many times servers behave very differently. Sometimes servers even reboot, or maybe network devices even reboot while processing these type of traffic. Now this is one type of attack, right? How you can ensure, we know about this attack because these are different flags, but how you can test randomly, like you can enable any random flags within a protocol, and how you can test it. That capability is also available within Scapy using the fuzzing option. So we do it first, wherein it randomizes the field and it sends out packet with random fields onto the network or onto a server. So if I have to test this out, what I can do is I will just I'll create a packet with a destination IP of my server, and I'll use a fuzz option. Now what this will do, it will send out packet on using random source port, using random destination port, using random flags, using random whatever options are available within Scapy. It will randomize all those options and it can send out a lot of packets. So right now it has sent one. If I just add in loop command, now what it will do is that it will try to send that packet at a very high rate with all the different options set. Now, if you need to see this traffic, if you want to see, so this is my server where I'm sending the traffic. And let's say I'll just capture for port 80 now so that we can see what it is sending. And I'll just remove randomization from the port. So what it will do, it will send the traffic only on TCP port 80, but with all the other options randomized. Now, if you see here, it is sending out packets with random bit set in terms of flags, random bits for sequence number, urgent bits, what random options. So what this basically does is that if in case in future there is an attack, you can beforehand itself, you can validate how your server will respond to those type of packets or those type of connections, and how your firewalls will react to those type of traffic. Now, another very common thing is that you may want to send out certain payloads when you're testing, right? A certain type of payload. Let's say you want to test out whether a particular signature is getting triggered, or if you created a custom signature, whether that will get triggered when the traffic will come or not. So again, that is again also very easy. You can just send Now on this server, instead of fuzz, I'll just remove this. And what I can do is I can add a raw header on top of it. Now in this raw header, you can add anything you want, right? So let's say I add a raw header and I just put A, B, C, D, A, B, C, D, A, B, C, D. You created an IPS signature, which is supposed to detect this pattern. How will you validate it? You just create a packet with that particular signature pattern and you send it over the network and it will send that packet to that destination server. But again, as I mentioned, that whenever you are running this into the network, just please be sure, because it may trigger some of the intrusion signatures. It may look like an attack onto the network. Now, let's say I want to send out just an ICMP reply. Any one of you heard about the Smurf attack? Yeah. So Smurf attack is basically when you send an ICMP request over to the network using a spoofed source address, and the destination IP would be for that subnet network, subnet, so that everyone else in the subnet will receive that ICMP request, and everyone will reply back to the same source, the source which you want to create a DOS attack on. So that is also pretty simple. You can just you can spoof the address, source address for that server. Let's say 10.0.0.50. I don't have access to the server, but I can create a packet. I can send it over the network using that IP address. And the destination would be whatever. If I want to send it to the entire subnet, I can just do 10.0.0/24. Now what it will do is that it will create that many packets for that entire subnet, and it will send those packets into the network. And if I add an ICMP header on top of it, that's it. It will send those many packets back into the network. Now, if I have to sniff the packet, if I can use the sniff option in order to capture the packet. This is similar to TCP dump. It's more like a TCP dump in the background where you can sniff the packet. Once you have sniffed the packet, then you can capture it and send it back over to the network. Another capability which Scapy provides is one second. Is that you can read the existing capture as well. Now I can, if I want, I can read the PCAP. I can read, there is a capture file which is available, which is demolab.pcap. I can read this capture file and I can look into each individual packet, and each individual packet I can modify and write it back to the same capture file. Now, this is pretty useful. Let's say if you want to provide captures to someone and you don't want to reveal your actual source address and destination address, then you can modify these capture files and write it back. So let's say if I have to write a certain packet, I'll take one of the packet 0. If I have to rewrite some of the details within the packet, so let's say I want to go into the IP header. No, sorry. Oh, it has, sorry, it doesn't have an IP header, so that's why. Let's see another packet, maybe fourth packet. Okay. Now, this packet has a source address of 10.0.0.7 and a destination address of 10.0.0.12. If I want, I can just rewrite the IP address, the destination IP, to whichever IP I want. Let's say 10.50.50.50. And it has rewritten that address. I can now write this packet back onto the Wireshark using the write pickup option, right? So there are two options. You can again go using this for packet in packets. You can do write pickup. You create, I'll just add something else, demo lab 10. Sorry for that. And what this has done is it has rewritten that capture file with the new information that we have provided. Okay, so that way you can read the packet, you can understand what is there in the packet, and then you can send it back over to the network, or you can send it to someone who needs to work on that capture. And in 30 minutes, that's all I could cover. There is a lot of options which are available. If you just go into the Scapy's website, there are a lot of examples which are present. There are a lot of online resources also available. If you want, you can just, my email address is available. You can reach out to me. If you need any help, I will be more than happy to assist with any of these things. And that's it for